Okay, now we'll discuss something like AI driven NVS approaches. So novel view synthesis using AI. So in AI, what happens is that like input, so we will have the same input like images along with the camera poses, viewpoints. Now what we will do is that we will train a neural network. So there is a technique called neural radiance fields. So in neural radiance fields, what we do is that we train a small neural network. Like we'll take a small neural network and we train it, and it will be a supervised training. Supervised. So in supervised learning, uh, we train the model that okay, these are the images, these are the viewpoints. So and then it will learn that okay, the image from this angle it looks like this, from this angle it looks like this, from this angle it looks like this. So it will learn the neural network. So we train the neural network to represent the scene as a cloud of density and color. So how we train that we will see very soon. We will come to that how exactly the training will be done to get an idea. But like the idea is that okay, input I gave, there is a neural network, we trained it, how we trained it, that we'll discuss very soon. Then it will generate output. So we will get learned scene representation. It can be a implicit function or voxel grid, and output is the photorealistic novel view. Okay, now let us see how we will be like neural radiance field. If I talk about here, I train a small neural network. How I train? To render a pixel, we shoot a ray into the cloud and ask the network how much light is reflected here. So the idea is very clear. See, once again, I'll tell you, in neural network method, what we do is that we need lots of data. So I have lots of images along with the viewpoints. I give it to the neural network. Neural network will learn that, okay, from this angle, the images look like this. And what it will learn is, it will learn the cloud of density and color. Like, like image, the distribution of pixels and the color, the intensity, like in that distribution, the color intensity. So the neural network, for every image, it will learn that okay, from this angle, this is the cloud density, wherein the distribution of pixels and the color. From this angle, this is the cloud of density and color. From this angle, this is the cloud of density. So whatever angles we have covered, so from different angles, it will learn the cloud of density and color. Now what will happen is that the idea is that now let us suppose I want to render a image or a 3D scene in a completely new angle. So what I'll do is that I'll shoot a ray into the cloud and ask the network, I'll query the network that okay, for this coordinate, and the angle is this. So shooting the ray means I'll tell the neural network that okay, this is the camera angle, and for this particular coordinate, what will the pixel look like, the 3D pixel will look like. That is the query I will give to the neural network, and it will tell me okay, the pixel density should be this, pixel intensity, color intensity. So in this way, what I'll do is that whatever the camera angle is, I have to send many queries. Like for every point, I have to send a query, every coordinate XYZ, and it will give me the information. And using that, I'll create a photorealistic 3D scene. And the best part of this is it will cover unknown regions as well, which we have never seen before. It has been synthesized. So this is like the approach of novel view synthesis. It's a modern method. Now the advantage of it. Okay, so before that, so now it's very clear that okay, input we have the images and the camera poses. Then we have a neural network, which is the learned scene representation. And then output will be the photorealistic novel view. Now neural radiance fields, the advantage is that photorealistic handling of light, transparency, and reflection. So, uh, as compared to classical method, like neural radiance field method, it is very good in learning light, transparency, and reflections, because here we are dealing with the pixel intensity. So it can very easily learn light, transparency, and reflection, and it will take care of that while generating the novel images. And the cons is it is extremely slow to render. Why it is slow? Because we have to query neural networks a lot. For every coordinate, we have to query it. So originally it took minutes per frame. So in order to render a frame, it may take minutes. So it can be like very time consuming. Now, what are the key advantages? It works with fewer images, captures fine details, handles complex lighting, and produces photorealistic results. So this is like a very important advantage of AI driven novel view synthesis approach.